Hello, and welcome back to Business Statistics. Today we're covering Chapter 8, which is all about sampling. So you might remember in Chapter 1, we learned the terms descriptive statistics versus inferential statistics. And as you might remember, descriptive was more about collecting and presenting the data, while inferential was more about making estimates and drawing a conclusion, and then making a decision. So in a population, we take into account everyone, for example, the voters in an election, but in a sample, we just take a subset, for example, say 1,000 voters selected at random. Now the reason we choose a sample is because it's less time consuming and much less cost. So in simple random samples, every object has an equal chance of being selected. Now, in estimation, we used an estimate of the population average or a mean using the sample mean, mu. So in hypothesis testing, we use evidence to test the claim. Now, a sample distribution is distributed across all possible values. And these are divided into 3 sampling distributions of mean, proportion, and variance. So we want to get to know these fairly well since we're going to be using them the rest of the term. Now let's first take a look at the sample mean. Now in the example I'm going to show you next, we're choosing 4 people, so that's going to be our n value. The random variable is going to be x, which are the ages of these people. And the values of x are going to be the ages between 18, 20, 22, and 24. Now, we'll develop a sampling distribution and find the mean mu first, and then we will take and find the variance. Now, let me show you how we would do that in Excel. So in this population example, as I mentioned, since we have n equals 4, the ages of the 4 individuals, which are going to be A, B, C, and D, are going to be 18, 20, 22, and 24 years of age. So to find out the mean, we use this formula, which is the sum of the x ages divided by n, which are the number of people. So in this case, fairly standard, we are just going to add the ages that we looked at before, which were 18, 20, 22, and 24, and divide it by 4 because that's the number of people. We can also use the formula for average to do that sample as well. So if we were to do that, all we need to do is use the formula average, so it's equal average, and then we select the values C4 through C7, and it's going to give us 21. If you wanted to do that manually, all you have to do is just add 18 plus 20 plus 22 plus 24 divided by 4. Now, the next item that we want to take a look at is the variance. So in the case of the variance, what we want to use as a formula is the square root of each of these ages, x, minus the mu average, so 21. Then we square that value and divide that sum by n. So this looks a little more complicated than it really is, but in reality, it's not that difficult of a formula. So what we're going to do instead is come in Excel and look at the values by taking each of these values of ages, subtracting the average 21, squaring it, and then adding the next one. So in this case, we're going to do 18 minus 21 squared plus 20 minus 21 squared plus 22 minus 21 squared, and plus 24 minus 21 squared. Then we're going to divide everything by 4, and we're going to take the square root of that. Now, if you're not familiar with Excel and how to do that calculation, the way you do that is you write equals SQRT for square root, and then you're going to open parentheses, take that 18 minus 21, and to square it, you do a caret top 2, and that's going to square this value right here. Then we're going to add the next segment. So 20 minus 21, we would need to, again, do the caret top 2 to be able to square that value, and so on. And then at the end, we're going to divide the whole thing by 4. The value of that is equals 2.2. Now, this is to do the sample, but it will give us the variance of 2.2 for the sample of A, B, C, and D. Now, what happens if we want to do it for the whole population? So all the observations between the ages of 18 to 24. Then if that's the case, what we want to do is we wanted the mu average is actually going to be the same. We're still going to get 21 for the average, but the variance is going to shift a little bit. And so the reason why it's shifting is because we're going to be including every single value here, so between 18 and 24. So instead of doing just 4 values as before, where we were doing 18, 20, 22, and 24, here we're going to do 18 minus 21 squared plus 19 minus 21 squared, and so on all the way to 24. That value is going to be 1.58. So just remember that when we calculate the sample mean for the sample, it's going to be the same as for the population, but for the variance, it is going to change because that now we're including all the population between, in this example, from ages 18 all the way to 24, which in this case ends up being 1.58. Now, the next area that we want to take a look at is finding the population normalized. So as I mentioned, since the mean is going to stay the same, the variance sigma will shift. The z value of that sampling distribution will use the formula z equals x minus mu divided by the square root of sigma over n. So again, that's a formula that we're going to get more acquainted as we go. But just remember that that if the population is normal with a mean u and a standard deviation of sigma, then these are the formulas that you're going to use when they're normally distributed. Now, as sampling distribution properties, when we sample a population, the mean for that distribution remains the same. But the curve for the sample is steeper, while the sample population area is actually larger. So the next area of this chapter that we are going to get into is the central limit theorem, which will apply evenly if the population is not normal. Now, I would suggest looking at the central limit theorem YouTube by 365 Data Science that talks about it in more detail. And the central limit theorem, as I mentioned in the past, is one of the most important concepts in statistics, so you do want to become well acquainted with that one. Now, keep in mind that the larger the sample, the curve is more normalized around the mean. So we say that if n is greater than 25, you will have nearly a normal distribution. As you might remember, in other chapters, we used an example where we tossed a coin 10 times and we started getting closer to a 50-50 heads or tails, except for a couple of times that you might have gotten a deviation normally the more you increase it, the more likelihood that you're going to get a 50-50 chance. And so this is the same concept, and it's using n greater than 25 to be able to reach that limit. Now, there is a section in this chapter that talks about sampling distributions for sample variances, and there is a good but a little bit longer YouTube called The Sampling Distribution of the Sample Variance by J.B. Statistics that you might want to check out while you're doing the homework for this section. Now, the book also introduces us to the chi-square distribution, which is a family distribution depending on the degrees of freedom. And there is also a good YouTube on this one as well that's called Sample Explanation of chi-square by David Eisenberg, which I strongly suggest you take a look as we will use chi-square more in the chapters to come. Hope that was helpful, and we'll meet up on the next chapter of Business Statistics. Have a great one.